Okay, continuing 6.2, let's consider the graphs of cosecant and secant. And then we'll derive their inverses. Okay, so x and y coordinate axes, remember, in this case we're going to be using x and y as opposed to theta and f of theta, but same difference. Okay, so let's have pi over 2, negative pi over 2, 1, and negative 1. Okay, so sine starts at 0, goes up to amplitude, back down to 0, and is symmetric with respect to the origin. So cosecant would meet at the peaks and the troughs and would have asymptotes wherever sine went through 0. So cosecant will meet at the peak, go off towards the asymptotes in both directions. So what I've done here is I've only plotted that part of cosecant that is 1 to 1. So if I were to take the inverse, so basically cosecant would go up like that and down like that if it were to continue on, but I didn't plot that part because I want to restrict my domain between negative pi over 2 excluding 0, because I can't have 0. So if I were to plot the inverse function, what I'd have to do, so x and y coordinate axes, I'm swapping all instances of x and y. Okay, so on my x I have 1, and negative 1 on my y-axis I'll have pi over 2, and negative pi over 2. However, my vertical asymptote, which was at 0, will now become a horizontal asymptote at 0 for the inverse function. Okay, I also know that I have the point positive pi over 2, positive 1, so I'll have the point positive 1, positive pi over 2. And as my values for x approach 0, my values for y become infinite. So hence, as my values for x become infinite, on the inverse function, my values for y approach 0. Similarly, I have the point negative pi over 2, negative 1. So I'll have the coordinate negative 1, comma negative pi over 2. As my values for x approach 0 from the left, my values for y become negative infinite. So as my values for x become negative infinite, my values for y approach 0 on the inverse function. So this is y is equal to cosecant inverse of x. So note the domain here. The domain is, actually it includes negative pi over 2. It stops at 0, it does not include 0, starts again at 0, and goes to positive pi over 2 inclusive. And that's actually the range of the inverse function. Let me draw that a bit more curvy. Okay, so notice the range is going to exclude the region between negative, sorry, what am I saying? Yeah, the range of this. What is the domain of my inverse function? Notice the domain of the inverse function is from 1 all the way to the right, from negative 1 all the way to the left. So the domain of this inverse function, it's interesting to note, is from negative infinite to negative 1 inclusive, and then it's from 1 to positive infinite, but nothing in between. Okay, so let's do the same analysis for secant, right? This was cosecant. So now let's do the same analysis for secant. So x and y coordinate axes. We have pi over 2 and pi. We have -1 and 1. So cosine would start at amplitude. Looks something like so. Oops. Draw this a bit better. And I know that the reciprocal to cosine will have a vertical asymptote wherever cosine goes through 0. They will meet at the peaks and the troughs. And secant will go towards the asymptotes asymptotically. And of course, I've only plotted here that portion of secant that is 1 to 1. Okay, so plotting the inverse function. Let's go ahead, x and y coordinate axes. X and y. So I'll put pi over 2 and pi on the vertical axis and +1, -1 on the horizontal axis. Now my vertical asymptote turns into a horizontal asymptote at pi over 2, swapping all instances of x and y. I have the point 0, 1. So on the inverse function, I'll have the point 1, 0. As x approaches pi over 2, y becomes infinite. So as x becomes infinite, y approaches pi over 2 on the inverse function. I have the point pi, -1. So I'm going to have the point -1, pi on the inverse function. And I notice as x approaches pi over 2 from the right, my values for y become -infinite. So as my values for x become -infinite, my values for y approach pi over 2. So this is a graph of y is equal to secant inverse of x. Okay, so let's note the domain again. So note the domain here is from 0 to pi, excluding pi over 2. So the domain here can include 0. Goes to pi over 2, it cannot include the asymptote, starts again at pi over 2, and goes all the way to pi inclusive. And note that that is the range of the inverse function. Okay, but what is the domain over here? Well, the domain, it's interesting to note, goes from -infinite to -1, right? Everything from here left. Oh, why did I put it on the asymptote? So everything from -1 to the left, and everything from +1 to the right. So union everything from +1 inclusive all the way to the right. Okay, so definition. Okay, so let's let y be equal to cosecant of x for x. Well, do I have to restrict my domain? Let's see. Yeah, it looks like I'm restricting my domain for cosecant between -pi over 2 and pi over 2, excluding 0. So between -pi over 2 to 0, exclude 0, then start again on the other side of 0 to +pi over 2. Then the inverse cosecant, then, let me put it this way, then inverse cosecant of x. Inverse cosecant of x. That's what we're defining. Inverse cosecant of x, denoted by y is equal to cosecant inverse of x. alternately, we can use the arc notation, so ARC, arc cosecant of x, has domain, from negative infinity to negative 1, then from 1 to infinity. Is that true? Let's see. Yep, looks like that is the domain. And range. Well, the range should be the same as the restricted domain. So that would be what? From negative pi over 2 to 0, union 0 to pi over 2. And we want to note, of course, if I can write y is equal to inverse cosecant of x, or cosecant inverse of x, rewriting this without the inverse is equivalent to x is normal cosecant of y. Swap x and y. Okay, so definition. So if I let y be equal to secant of x, for x between, well, let's see, where would x be? Looks like it's between 0 and pi, excluding pi over 2. For x between 0 and pi over 2, start again on the other side of pi over 2 and go all the way to pi. Then, inverse secant of x, inverse secant of x, that's what we're defining, denoted by y is equal to secant inverse of x, or alternately arc secant of x, has domain. Well, what was the domain on the inverse secant? Well, from negative infinity to negative 1, minus infinite to negative 1, inclusive, union from 1 to positive infinite, and of course range, equal to the restricted domain, that is from 0 to pi over 2, then starting again from pi over 2 to pi, non-inclusive at pi over 2. And we of course note that we can rewrite y is equal to secant inverse of x as x is equal to normal secant of y. Okay, so shall we do a couple problems? So for example, let's evaluate the following. Okay, so number 1, let's say we have y is equal to cosecant inverse of negative 2. So if y is cosecant inverse of negative 2, this is equivalent to saying that negative 2 is normal cosecant of y. Okay, so at what angle is sine the reciprocal negative 1/2? Well, that would be at negative pi over 6, agreed. And that is that in between. Where is cosecant invertible? Between negative pi over 2 and pi over 2 without 0. Is that, so let's note that negative pi over 6 is indeed in the interval between negative pi over 2 inclusive, yes, inclusive at negative pi over 2, excluding 0 to positive pi over 2, so we're set, check mark. Okay, let's just do one more. I think you guys get the idea. So number 2, where shall I put it? So let's have y is equal to secant inverse of 2 root 3 over 3. Once again, I've rationalized this, but we can, quote, unrationalize this. So we have y is secant inverse of 2 root 3 over 3. Well, I'm going to say that this is y is equal to secant inverse of 2 over root 3. Well, that's the same thing as saying 2 over root 3 is normal secant of y. And that's the same thing as saying root 3 over 2 is cosine of y, the reciprocal. Well, that means that y must be equal to, where is cosine root 3 over 2? Pi over 6. Okay, let's also note pi over 6. Is that in the allowable interval for secant inverse? Well, let's see. Secant is invertible between 0 and pi, excluding pi over 2. Okay, so between 0 and pi, excluding pi over 2. Check mark. Okay, so let's see. What shall I do? I think I will do one more thing before the next video instead of making it a different video. So let's note, because I'm not going to do any examples for this. I think we understand it by now. Cosecant of cosecant inverse of x, of course, will be x. But I need to restrict my values of x to be within the allowable domain of cosecant inverse. So let's look at the cosecant inverse. Notice the domain excludes the interval from -1 to 1, but it's everything else, okay? So from minus infinite to -1, start again at +1 and go on forever. Okay, what if I did it backwards? If I first did cosecant inverse of normal cosecant of x, well, that's x for all values of x on the allowable invertible part. Okay, so let's go to cosecant. So cosecant looks like it's between negative pi over 2 and pi over 2, excluding 0. So that's between negative pi over 2, excluding 0, and then to positive pi over 2, inclusive at the end points. So similarly, if we have secant, a secant inverse of x, of course this will be x, provided x is between, well, let's look at the domain of the inverse. So secant inverse has values of x that exclude the interval from -1 to 1. So it's also from minus infinite, excluding the interval from -1 to 1, and onwards forever. So secant inverse of secant of x, that's also going to be x. But now I have to restrict secant. Where is secant restricted? Well, it's between 0 and pi without pi over 2. Okay, so it's between, including 0, I'm excluding pi over 2, and I go all the way to pi inclusive. Okay, I'll stop here, and one more video for this section is coming.